So this is lesson 8.3, solving right triangles, but it's really more about finding the measure of angles in right triangles if you're given some side lengths. So the objective here is I can use trigonometric ratios to find angle measures in right triangles, and also using that information to solve real-world problems. So let's look at a couple warm-up problems. So first of all, we want to look at comparing an operation and that operation's inverse. So if you have addition, the inverse to addition is subtraction. So for example, if we have 1 plus 4, we get 5. And then if we have 5, we can then subtract 4 to get back to 1. So you can think of the inverse as undoing the original operation, or possibly think about it as going backwards. So 1 plus 4 to get to 5. Then to get back to 1, we need to do the inverse operation, so subtract 4. So then if we have the operation of multiplication, its inverse is division. And what about if something is squared, the x squared? So to undo that, it would be the square root of x. So for example, if we have 3 squared, that gives us 9. To undo that, get back to 3, we would take the square root of 9, and that would equal 3. So the inverse undoes the operation or the function. All right, here's another review problem from the prior lesson. So if we have a right triangle, this angle is 40 degrees, and the measure of this guy down here is 5. And what I want to try to do here is find this length of AB. So if I take the cosine of 40, which is equal to the adjacent leg over the hypotenuse, I'm just going to call it x here. And now I'm going to solve this. So multiply both sides by x to get it out of the denominator. And then what we'll do is divide both sides by the cosine of 40. And then we'll just put that into a calculator and get our answer. So in this case, x is 6.53, or we can say the length of AB is 6.53. Okay, so now let's look at an example of how we can use trigonometric ratios to solve a real-world problem. So we have here is the Leaning Tower of Pisa, and what I want to do is calculate the angle it is leaning. So I'm going to start by marking some information I know. So it is known that that is about 179 feet going up the side of the Leaning Tower of Pisa. Then what I'm going to do is drop a line straight down here and then connect this here. What that does, it makes a right triangle. So the red line is the hypotenuse, and the yellow and the green line are the legs. So if we do that, this distance down here ends up being 17 feet. Okay, and to help us talk about this problem a little bit more, I'm going to focus in on this angle here and call that vertex A, or angle A. This one up here B, and then this one down here C. So now I want to look at the different ratios that we can make from this angle A here. For example, the tangent of angle A is the opposite, the green one here, over the adjacent, the yellow one. So then the cosine from angle A, cosine is the adjacent one over the hypotenuse. And then finally, the sine of A is the opposite over the hypotenuse. So we're trying to find the measure of angle A. So the cosine of that angle will equal 17 over 179. And that will equal approximately 0.0950. Now what I could do is, in the calculator, just try a bunch of different angles. Put 10 in for A, find the cosine of 10, see if that was equal to this, and then adjust the measure of angle A over and over again until finally I find the measure of angle A, where I take the cosine of it, and it will equal this number. That's one way to do it, but there is a lot faster way of doing this, and that is using the concept of an inverse function. So if we have something that can undo this cosine of A, have it just be A, we can do that to this side and then do the same thing to the other side. So we write the inverse cosine as the cosine, the little -1 there. Now this -1 is not an exponent. I know it looks kind of confusing here because we write exponents like this also, but in this case, that -1 means it is an inverse. So the inverse cosine of the cosine of A will equal, then we're going to take the inverse cosine of the right side also. So the inverse cosine of 17 over 179. Now if we take the cosine of A, then take the inverse cosine of it, it undoes the cosine of A, so it ends up being just A on this side. So A will equal the inverse cosine of 17 over 179. So this is where on your calculator you need to figure out how to calculate this. On some calculators you hit the cosine button twice, so this little -1 here shows up, or you might hit the second button and then cosine to get it. So what I'd like you to do is try putting this into a calculator here and see if you can get your calculator to give you an answer of 84.55. Alright, so now we know that the measure of this angle here, A, is 84.55 degrees if the hypotenuse side here is 179 feet and this leg here in the bottom is 17 feet. So it's not only the inverse of cosine, you can also have the inverse of tangent or sine. So the inverse of tangent of the opposite over the adjacent sides will equal the measure of angle A. And the cosine, which we just did below, the inverse cosine of the adjacent over the hypotenuse will equal the measure of angle A. Finally, the inverse sine of the opposite over the hypotenuse will equal the measure of angle A. Okay, so let's go ahead and try using this in another situation. Okay, so I want to use a little bit of time practicing our calculator to find each of these angles. So the first one we'll need to put into our calculator as an inverse cosine of 0.87. And one thing to note is that you do want to make sure your calculator is in degrees and not radians. So give this a try right now on your calculator and make sure you get 29.54 as your answer. Okay, so we're asked to list the angle measure to the nearest tenth of a degree. So I'm just going to say the inverse cosine of 0.87 is about approximately equal to 29.5 degrees. And I do want to point out that when we say this, we say the inverse cosine of 0.87. We don't say cosine to the -1. That to the -1 implies that that's an exponent, and that is not an exponent. That means that this is an inverse function of cosine. Okay, so then for the inverse tangent of 0.71, put that into a calculator and make sure that you get the inverse tangent of 0.71 is about equal to 35 point, and it won't be 3 because we need to round it to the nearest tenth. So Since this value here is 5 or more, we'll round that to 2.4. All right, so I'd like you to try one on your own. So given this ratio here, what would that angle measure be? So basically find the inverse sine of 0.85. So one type of problem that you will be given is a right triangle like this one, and you're given us some of the information and you're asked to find the rest of it. So for example, here we're given 2 side lengths. We will need to find the third side length and also the angle measure of these 2 angles here. There's always more than one way of solving these problems. So I'm going to show you 2 methods here, but you will not be restricted to doing it by these 2 methods. Okay, so I'm going to label the first one method 1, and I'm just going to mark the 3 sides of the triangle with different colors to help organize my work as I go through this problem. So I'm going to first focus on this angle here, angle R. And so the cosine of angle R is the adjacent over the hypotenuse. So I'm going to focus on trying to find out what this measure is. So cosine of this angle will be 5, that's the adjacent, over 5.7, which is the hypotenuse. But we want to find out what R is. So what we're technically doing here is taking the inverse cosine of both sides of this equation. And what that does, it gets R by itself. So if we take the inverse cosine of the cosine of R, we just get R. And then we will have the inverse cosine of 5 over 5.7 on the right-hand side. So from here, it's just a matter of putting this into a calculator. So I did that, and I got it approximately equal to 28.6944, and then a bunch of other numbers. But here we're asked to round it to the nearest degree, and since this is 5 or more here, and we'll round it up to the measure of angle R up to 29 degrees. So next I want to find the measure of angle T. Well, I could use the sine of that angle, or inverse sine of 5 over 5.7. I know that angle R and angle T need to add up to 90 degrees. And so I can just subtract 29 from 91 and get 61 degrees for angle T. Okay, so last is this line segment here, ST. And what I'm going to use is tangent of angle R. So tangent of angle R is ST over 5, opposite over the adjacent. So we know what the measure of angle R is, and I'm not going to put in just 29 degrees. I'm going to put in 28.694, just 28.69, and that will make my answer more precise. So you don't want to round until the end. So here we're going to multiply both sides by 5, and then just take 5 times the tangent of 68.69. So then we get 2.7363 is about what the length of ST is. So we need to round to the nearest hundredth. So that 6 there, we'll make this round it to a 4. So 2.74. Okay, so another common method here, particularly with the side lengths, is to use the Pythagorean theorem. Usually when I see a right triangle and I know 2 side lengths, I want to find the third, instantly I start thinking the Pythagorean theorem. So square the 2 legs, so this length here squared plus 5 squared will equal the square of the hypotenuse. So I'll start by just squaring the 5 and squaring the 5.7. And then subtract 25 to get the ST squared by itself. And then we'll just take the square root of both sides. So then I get that ST is approximately equal to 2.7368. So because of rounding, it's going to be slightly different than the other one. It's just rounding here. But for answer, we need to round to the nearest hundredth. So it ends up being 2.74. Okay, so coming down from Mount Hood, in Government Camp, there is a sign that says 6% next 5 miles. And what that means is it's a 6% grade. And another way of saying that is for every 100 feet you go forward, you go down 6 feet. So 6%, 6 out of 100. So I'm going to draw a picture of the situation here, and that will help us solve this problem. Because what I want to do is find out at what angle is the road when you see a sign like this. Okay, so I'm going to start off by just drawing a straight line here. And I'm going to assume that we see the sign here. And we just go downhill. And what this is saying is that for every, we'll say 100 feet, we go down 6. So 6%, 6 out of 100. So now I want to find out what is the measure of this angle here. Well, I'm just going to label that angle A so that I have something to work with. And since from angle A, we know the side opposite and the side adjacent. So since all we know is opposite and adjacent, I know I'm going to be using tangent here. So the inverse tangent of 6 over 100 will equal the measure of angle A. So I'm just going to put that into a calculator. And I get 3.4336 is about equal to the measure of angle A. And so measure of angle A is about, and this problem didn't say what to round it to. So I'm just going to round it to the nearest tenth of a degree and say that the measure of angle A is about 3.4 degrees. So now if you see a sign like this, it says a 6% grade, you will know that the road has an angle of about 3.4 degrees. Okay, so on the next slide, I have one more for you to try. It's like the problem before this one, so hopefully you have good notes on it. If not, I suggest going back and checking out that video again. So it'll be one for you to try and a couple of questions to answer in Edpuzzle. Okay, so on this problem, you'll want to find out the length of DF, the measure of angle D, and the measure of angle F.